Here, let me see. 3, 5, number which one?
7.
Okay. Yeah, all right. Sorry. So what I would highly suggest for this problem is to draw a picture. So it's 60 foot by 26 foot. And we're going to put little 1 foot square. So I'm just going to do the bare minimum of the beginning of a picture. All right, hold on. Sorry. So number 7 is itself not a word problem. You actually know everything. So it's not a word problem. It's really just can you figure out the number? There we go. So it is 60 foot by 26 foot. Holy shit. All right. So don't hire me to make a pool for you or something. All right. So it's 60 foot. I actually have something that would draw a straight line for me, but I can always forget. 60 foot by 26 foot. So when you start placing square tiles down around this thing, right? They're 1 foot by 1 foot. They should be right on top of each other, really, but oh well, too bad, Jeff. I am drawing this horribly. But you'd have to count. I mean, how many square tiles would go along here?
60.
All right. And of course, you've got to be worried about right here. So that's all I'm going to do. That is it. I'm not going to do any more. In fact, I'm about to erase this. Here it goes. It's going away. Bye. All right. So my suggestion on number 7 is draw a picture. You don't have to draw every tile. Do you understand? You just have to get a feel for what you have to be careful about. That's all. So it should be really clear as to what the answer almost is. And then you have to be careful. Let me see. Do they even say something about it? No. You have to be careful about, you want to go all the way around. So you got to be careful about certain areas. That's all I'm going to say. I don't want to, I almost give the answer away. I basically gave the answer away if you're paying attention to how I drew it. I don't know. Is that more than you knew before you asked the question, or is that?
Yeah, definitely. I
Okay.
think I got it from there.
All right.
Yeah, Professor, section 3, 5, and 3, 6 is not at the module yet.
Oh, okay. Dadgummit. Yeah, it's just crazy trying to keep up with all the little pieces parts nowadays. All right. Now, obviously, if I don't put up a place for you to turn homework in, you could still do it, right? I love it. In another class, somebody's like, I didn't do the homework because you didn't have a place to, what? You can still do the homework anyway, sorry. So that's going to take me a minute to figure out due dates and stuff, but anybody else have questions from the quiz, from the homework, general question about how things work? The average on the quiz was like an 85, but I am concerned there were several people who seemed to really not understand points, intercepts, lines. If you didn't do so well on that quiz, you really need to come to office hours, go to tutoring. We're going to get deeper into graphing stuff. So you really need to have a good grasp of the basics. Okay. So let me know anything else while I figure out these due dates. All right, May 5th. Anything else? I just want this over, Jeff. Can this be over, Jeff? It will be. And I already forgot. What was it? May? I can't remember now. Shoot. All right, May 5th. That's right. All right, so I got to work out the due dates for these homework assignments. No other questions? Homework questions? Anything? Nothing? Okay.
How about number 4 on 3-5?
Caitlin's like, let me give this guy something.
I did promise to come with questions, and I always keep my promises.
Good, thank you. So which one again? Sorry.
Number 4. It's like that big word problem.
Oh, the Barkley Marathon weirdness, right?
Yep.
All right. So let me say this. If I start, all right, let's say that I'm here at point A, and you're here at point B, and we are, holy shit, we are 50 feet apart, right? You with me so far?
Yeah.
Okay. If I start walking in this direction and you start walking in this direction, and let's say that I'm going a little bit faster, we're going to meet somewhere like right here, correct?
Yes.
And it makes sense. If I'm going a little faster, I'm going to get a little further.
Right.
And meet you closer to where you started. That kind of makes sense.
Mhm.
So this is the distance that I've gone, and this is the distance that you've gone, right?
Mhm.
So what must be true about the two distances?
That they're both going to be different because we're both traveling at different paces.
Okay, they're both going to be different, but I want something very specific.
They're both 50 feet?
No, they can't both be 50
Oh,
feet.
yeah.
They must both do what to become 50 feet? The distance I went and the distance you went. Anybody else can chime in too.
Add it together.
If I add them together, they have to
Okay.
make 50 feet, yes?
That's what I was thinking, but I just could not express it in words.
Okay. I'm with you.
Early.
You're fine. Now, this has a huge thing to do with this problem because they're on the last lap. I know it's circular, but that doesn't matter. They're on the last lap, right? They start here, and this is asking me how many hours would it be until they meet? So this guy's going to go this way, and this guy's going to go that way, and the faster one is going to make it a little bit further.
Mm-hmm.
They're going to meet like right there. Isn't that basically this?
Yeah.
Like if I took that circle and just kind of opened it up.
Yeah.
It's the same thing. So that's what they mean with this last sentence, right? How long is the loop?
20 miles?
20 miles. So that's like my 50 feet. Yes?
Mm-hmm. Yeah.
And I know that one is going a little slower than the other one.
Yeah.
So the trick is, so here's the distance of the faster one, and here's the distance of the slower one. Is that cool?
Yeah.
I want this really. So the distance the faster one went is here, and the distance the slower one went is there. If you can write an expression for each of these, what's the formula in general for the distance if you know the speed and the time, the rate of travel and the time traveled? Does somebody remember the formula for distance and knowing the rate and the time? No, if you're going 5 miles an hour for 2 hours, how far did you go? If you're going 5 miles an hour for 2 hours.
10 miles?
How far?
10 miles?
10 miles. Didn't you take the rate you're traveling multiplied by the time? Do you guys remember D equals RT, dirt?
Yeah.
Misspelled. I like it. Dirt. D equals RT. Right.
Gotcha.
Got me some dirt. Okay. Do you know how fast each one of these people is going?
One's going 2 miles per hour and the other one's going 1.92 miles per hour.
So yes. So we know the rate of the faster one and we know the rate of the slower one. I like it. Do we know and what is the time they're traveling? I have no idea, but I'm going to put the time of the faster one and the time of the slower one. Now, what's true about the two times? Is one traveling longer than the other one? They start, and then they meet. Did one go for longer than the other one? Not a longer distance, a longer amount of time. Did either one of them go for a longer amount of time when they meet?
No, because they start at the same time.
They start at the same time, and of course they have to meet at the same time. That would be weird if one met the other one before the other one got there.
Right.
Okay, so to be honest then, this, I don't know if you guys are still with me or not. This is not an easy problem. So to be honest, I can use the same symbol for time for both because they're equal.
Mhm.
The only time you can use the same letter for two different things is if those two things are actually equal. And one last thing I'll write down. What is DF plus DS? What's the distance this person went plus the distance this person went?
It's 2 miles.
Stop. No.
Wait.
Don't look at this business. Just what is it? I knew from the very beginning how far this was all the way around the loop.
50 feet.
No, that was my made up shit.
Oh,
Talking about number 4.
20 miles?
20 miles. Okay. All right. Now that probably confused people, but I mean, this is what goes into this. So use a letter to represent the time until they meet. So that makes sense to use the letter T. Write expressions for the distance traveled by each racer. Okay, I've got to use this equation, and then I can write an expression for the faster one, and an expression for the expression. What am I drinking? An expression for the slower one. This is not impossible. This is not easy, but it's not impossible. In fact, I've already got the equation set up for you. You just have to throw the numbers in, and then you have an equation you can solve for T. And that's what they want. They want to know how long, how many hours until they meet. All right. I'm going to clear all this away. So I really want you to understand. So let me come back in here with something that we've already said. So I know that the distance is, are you guys cool with me putting a little F down here and a little S down here?
Yeah, it's fine.
There's 2 different people and they each went a different distance, right? But I know whatever distances they went, it's got to equal 20 because one person goes and the other person goes. So together they went the full 20 miles. There's no getting away from that. If you can write an expression for this guy, and I already had it written down for you, right? Distance equals rate times time. And you can write an expression for this guy, then you're going to have an equation with a bunch of t's in it that you can then solve for t. And of course, t means time, and the question said, how long, how many hours? So if I can solve for t, I'll know how many hours. I'll be done. I don't know, did anybody actually look this thing up? Barkley Marathon?
No, but I definitely wanted to. I'm just going to do it after class ended.
You're fine. Holy shit. It's something else. I'm like, no thank you. Okay, let me stop. All right, I'm almost certain what always happens in any algebra course I teach, there are people that sort of skip the word problem section. So if that is happening, stop doing that. Get in there, try them out, right? Are you going to be perfect on the first try? No, probably not. That's not the point. You'll notice drawing pictures is a huge part of the process very often. I want something visual I can kind of anchor myself with. All right. Okay. Anything? Anybody else have something? Question? You guys okay? No? Okay. All right, if there's no more questions, we're going to get back into where we left off. Let's see. So we finished section 3.6. Section 3.6 should be a lot more straightforward than section 3.5 for sure, right? So if I were you, I might try some 3.5 and then I'll take a break and do some 3.6. And then I'll come back to 3.5 and then I'll take a break and do some 3.6. 3.6 should be more straightforward. 3.6 is coming back to equations, and I can throw stuff in and I can get outputs, and yeah, it's a little bit more straightforward. It's not going to be, all of it's going to be easy. Some of it's a little freaky. Okay. So I want to hear, look, there was a lot of issues on the quiz with interpreting slope and intercepts. Don't just pass by these sections. I mean, there's problems that I assigned for you to do, but then there's write-ups here that kind of review stuff. I mean, this is nice. I mean, and then they get into how to compute slope, and then they get into how to interpret slope. So yeah, when I ask you to interpret an intercept or interpret a slope, you've got to give me physical stuff. If I'm talking about a candle burning, you got to tell me about the candle and the time. If I'm talking about hiking, you got to tell me about the elevation and the time it took. And I mean, you've got to use the physical situation to explain what they mean. Okay. It seems like students sometimes don't believe that the numbers we get in math actually mean something. But that's the whole point. They mean something in the real world. Okay. So let's do this. We're going to do a little bit of 3.7 since there's no other questions. You can ask questions from the quiz also. If there's something in the quiz that confused you, you can ask about that. All right. All right, so let's talk about this. So what we're getting into in section 3.7 is finally formalizing something that we've had to do every now and again already, which is finding the equation of a line. Now let me ask you this. What is the minimum, if I had a line that I wanted you to graph, what's like the minimum amount of information I have to give you? Does that make sense? If there's a certain line I have in mind, what can I tell you so that you can draw it? There's a really simple answer, and then there's another not so obvious answer. Can you just tell me the most obvious answer? What's the quickest thing I could tell you so you can graph a line? What do you have to know? So I'm like, there's a specific line I want you to draw. All right. Okay. What would you ask? What could you ask? How is it this one? I don't know. So what I have to give you information. So what information could I give you so you will draw the line that I want?
The point or the slope. If we have a point or slope, we can draw, right?
Well, all right. So change the or to an and. If I only give you 1 point, can you draw a line from that? No.
No.
Right. How many lines go through the point 3, 2? How many lines go through the point 3, 2?
2.
It's interesting. Let me see. Now watch this. All right. I know this is weird questions. I understand. And I don't necessarily expect you to have the answer right away, but
You mean five?
line go through that point? Does that line go through that point?
No.
That line doesn't go through that point?
Hopefully obsidian.
Yes.
Of course it does. I drew it through the point. Does this line go through that point?
Meteorites. There are three
Yes.
types of meteorites.
Yes. Does this line go through that point?
Yes.
So let me ask this again.
The biggest thing that I have currently in this box is the aragonite.
Too much is happening behind you. Let me ask this again. How many lines go through any point? Don't say 3, because I just stopped.
Thousands of lines. A lot.
Sure. An infinite number.
Mhm.
There are an infinite number of lines that go through any point. I could just do this all day. I could do this all day. All right, Captain America, calm down. Anyway. Stay with me now. So if I give you 1 point, I actually have to give you one other piece of information. So like Wafa said, I can either give you a point and a slope. That's one way I can get a single line. So if I tell you, all right, why is this thing freaking out? Here we go. Let me bring these back in. So if I tell you it goes through 3, 2, and the slope is, what do you got, Jeff? 1/2. Can you draw the line now? What does it mean if I tell you the slope is 1/2? Can somebody tell me what that means graphically? What's the line doing?
But you guessed
1 up, 2 over.
Good.
You guessed the Sahara guess.
All right, thank you. So if I start at this point, I can go 1 up and 2 over. And now I've got a line. So the most obvious answer was just give me 2 points. If I give you 2 points, there's only one line that goes through 2 points. Do you guys agree with me? If I give you 2 points, can you draw more than one line that goes through both points? Nope. Right? And just be careful. We're sticking in 2 dimensions. Nothing weird. Okay. So I can either just go ahead and give you 2 points, or I can give you a point and the slope. All right. Now, so what I want you guys to do right now, based on what we just talked about, let me find some white space here. I'm going to clear this away. Here, let's do one more example together. I think I got some white space here. Here we go. Oh, shoot, there's chats. I can't do it. Oh, I see. Okay, that's fine. Let me see. Hold on. Here we go. Let's do one more together. So what if I have a line and it goes through. Jeff, why are you? Good Lord. All right, what language is this? I don't know. Line goes through the point -1, 3 with a slope of -3/2. All right, so let's graph this one together. Okay, so you got your paper ready. Draw yourself XY plane. Yeah, other dot. What are you doing? Draw yourself an XY plane. Maybe even make it straighter than mine. Let's go out to 5. Of course, the ultimate good thing would be to have some graph paper. I'm not going to number all these. All right. Blah, blah, blah. Okay, X, Y. All right. So now, bam. -1, 3. Okay, bam. That's where I know it goes through that point. What does this slope tell me to do? What's the words for slope again? What's the starts with R's?
Rise over run.
All right, and what's it mean when the rise is negative?
You go down the
Good.
y-axis.
So I go down 3, and then what does this mean?
Over 2.
Over 2. Kabam. So think of a slope as a set of directions, how to get from one place to the next. That's all it is. Go down 3 blocks and then over 2 blocks, and you're at my house. See you in a minute. Bye. Right? I mean, that's it. That's all it is. So I need to have a place to start and either a point to go to or directions on how to get there. So all a slope is a set of directions of how to move along a line. That's what a slope is. So from this point, I would go down 3, 1, 2, 3, over 2, 1, 2. So now I'm right here. Kabam. Oh, I can do this. Here we go, Jeff. Look at you remembering. Let me see here. I'm so excited now. Look at that shit. Oh, sorry. All right. Kabam. Look at that. Holy shit. Now I've raised the bar too high, Jeff. That's too bad. All right. Are you guys okay with this? I know some of you guys probably remember this kind of thing from before. I really want this stuff to make physical sense. A point, a place to start. A slope, a set of directions. All right, so guess what? Now I'm going to give you a problem to do on your own. Okay, so number 2. Line goes through, what do you got, Jeff? 2, -1, and it has a slope of, all right, Jeff, 5 halves. I like it. So I need you to graph this for me. Do this problem here. All right, so let's take a look here. So it goes through 2, -1. And then where I go from there? What's the slope tell me to do?
Go up 5 and over 2.
Good. So this tells me to go up 5, over 2. Become a 5. So from this point, I'm going to go up 1, 2, 3, 4, 5. Now I'm not going to put a dot yet because I haven't got to the next house. So now I got to go over 1, 2. So I'm going to be right there. And now I can do my little trick again. Gee. Cool. All right. Why does this make sense that it's kind of going up based on what I said, the information I gave? See how it's increasing as I go from left to right? Increasing? Why does that make sense? Wasn't the one we did earlier going down? Why? Why is this one going up?
Because it's positive.
Slope is positive. That means it's going to go up. So if I have a business and I'm looking at the profit graph, I want the slope to be positive, right? Slope is negative means I'm losing money. Oh, crap. Okay, I like it. So positive slope, your answer should end up going up. Negative slope, your answer should end up going down. As you read from left to right. Yeah, okay. All right, all right. So let me clear all this away. Let's see what this book gets into. Clear this away, go away. Here it goes, it is gone. So let's take a look here. Here we go. All right, so let's talk about some pizza. So you're involved in planning a year-ending pizza party to celebrate another successful year on campus. Oh, remember those days? As chair of the planning committee, you worked a deal with a local pizza place, $9 for a large pizza. That's not bad. It's probably not good pizza, but that's right. Pizza's pizza. The budget will allow at most $175 to cover the food. You'd like to know how many pizzas you can get in standard budget. Okay. So number one just says, just attack it directly. No algebra, right? So try it. Can you figure out how many pizzas? Don't say anything. Just how many pizzas can you get and stay under budget? All right. So who's got an answer?
19 pizzas.
Okay, 19 pizzas. Did anybody get a different answer?
No.
All right. So how did you get that answer?
Uh, 175 divided by 9.
Cool. Now, what exactly did you get when you did 175 divided by 9?
19.4 repeating.
I like it. And obviously you wouldn't go up to 20 because that would put you over budget, correct? So yeah,
Yes.
and you can't buy 19.4 pizzas. That are not going to appreciate that order. So I'm going to stick with 19. I like it. So that makes sense. All right. So a lot of students say, why do we have to go past that? Why can't we just stop at numbers? Why do you have to bring algebra in? Because this is a very specific answer to a very specific situation. There might be there might be other situations that I want to have something I can use real quick. What kind of let me see if you guys remember this. Is this a direct variation problem?
Yes.
Why?
Because if you spend 0 money, you get 0 pizzas.
0 money, 0 pizzas, and is it linear? Can somebody tell
Yes.
me the slope of this problem? What would the slope be? What's the rate of change of money spent per pizza?
$9 per pizza.
$9. See, so they just told us the slope, didn't they? People always kind of freeze up a little bit when they ask that. They're like, I don't know. They didn't give me any points. How do I calculate the slope? No, they told me it's $9 per pizza. That is a rate of change. That is a slope. So don't say anything. Do number 2. I just gave you all the information you need to do number 2. Don't say anything. Okay, now somebody else tell me, what's the answer to number 2? How much does it cost if I get 1 pizza?
$9.
$9.
C equal 9 times B.
Yeah, thank you. 2 pizzas would be 9 times 2 is 18. So, I mean, how do you find for any amount of pizza that I give, what did they say? P pizzas. It's going to be 9 times that. That's all, right? And that does look like the form of direct variation, but that's, that's not really that important at the moment. I like it. Okay, not too bad. Nothing too major yet. We got to clear all this away. I'm going to see what's the next thing they want from us. Yeah, and now something like this is going to be simple, right? Oh, I got some chats coming in. I can't handle all of it. Okay. All right. I'm going to assume that everybody could just kick this table's ass, correct? Whoop-de-doo. All you do is you multiply 9 times each one, right? So what's this? What's going to go here?
45.
45.
Yeah, exactly. So, I mean, whoop-de-doo, whoop-de-doo. Okay. And then you can graph it. So, I mean, these are not horribly difficult things. The next thing they ask you to do is graph it. So far, this is very similar to the last section. Okay, so they're sort of starting off with a problem we've done before, right? I'm not gonna, all right, so I don't know if we should do this. Well, yeah, this is probably a good review real quick. Oh shoot, let me get this in a better position. Okay, maybe, yeah, sure, we don't have to see that first point. We know it's 0, 0. So then this is 545. 10 what?
90.
90. So what's another way I could do this? I could just keep adding how much?
45.
Yeah, just keep adding 45. Jeff, you could do it. There you go, buddy. All right. And you can double check. What's 30 times 9? 270. Yay. So what do I have to be careful about? And of course, I'm not showing the first point. The first point is 0, 0, right? Just gonna get it on the screen. When I go to create this graph, what do I have to be careful about? What do I have to choose first? How do I set this up?
The number of the pizza.
Good. So somebody tell me what the scale of the x-axis should be, looking at the numbers.
0, 5.
All right, so it makes
15.
sense.
It's 5s, yeah.
10, 15. Pretty much they set up the scale for us just with the numbers we got, right?
Mm-hmm.
All right, that's too far. Okay. And of course, somebody else tell me what should the scale of this one be?
The cost.
It does represent
45,
cost.
45, 90.
Yeah, it goes by 45. Okay, that makes sense. Will it always be that easy? No. All right, anyway, so yeah, now when I plot these, they're going to be kind of, I've sort of set it up so they go perfectly diagonally, right? And of course, it's going to end up being a straight line. Okay, so hopefully, I'm sort of making an assumption here, but that problem should be desperately simple, right? It's a pretty straightforward problem. And of course, you connect the line, and then you'll be done. You do it, Jeff. Wow. Look at that. That's so beautiful. Sorry, especially for me. Okay. So nothing really too new there yet. So let me clear this away. I'm going to clear it away. Go away. All right, here goes. Bye. Oh yeah, and then we got inequality. So this one shouldn't be too hard. So this is almost like a review of everything we've done so far. So here is the formula again. I want to spend at most $175. So what inequality would that lead to?
Less than or equal to?
Sure, less than or equal to, but I mean the whole thing, not just the symbol, but what's the whole inequality? What's less than or equal to what?
Nine P is less than or equal to 175.
Yes, I want the cost, which is 9p, to be less than or equal to $175. And of course, we'll get the same answer we got in the first place, 19.4 repeating, right? When I divide by 9, okay. But now it's just a little more formalized in inequality. So if I divide by 9, woohoo, I get my p less than or equal to 19.4 repeating. So any number of pizzas up to 19 would work. All right. Okay. So that was kind of nice. That's a nice little review of everything we've done basically so far. All right, so let's get into some other freaky stuff here. Let's see. I'm going to clear all this away. Here it goes. There's not much there, Jeff. I know. Bam. Blah, blah. Oh, this is all right. This is not as interesting as I want it to be. Let's start talking about, does it do anything else interesting? No, let's get over here. Let's get to something more interesting. Get out of here. Go away. Here we go. All right. Whoa, this is almost too interesting. All right. Now, oh, this is going to be neat. Blood alcohol concentration. Right? And the 0.08 actually means 0.08%. So it's kind of crazy. That's all it takes. So here's the different things. I mean, the different levels you could have in your bloodstream for if you drink alcohol. So this seems to be a nice place to be. Relaxation, slight body warmth. That's nice. Maybe you don't want slowed reaction time and sedations. That's them. And then of course you get up here and then you're getting more and more trouble. Okay. So I'm not going to make this a public service announcement about don't drink too much alcohol, kids. So let's see. This first question, let me see. Where do they get into the interesting questions? Oh, God. Okay. So let's do this. This is where things get more interesting. John decides it would be a good idea to drive when he shouldn't. Okay. They do a blood alcohol content test at 2 a.m. and they find this level in his bloodstream. Now, it kind of makes sense that over time, the blood alcohol content's going to go down, right? It's not exactly true. I don't think that it's perfectly linear, but can you guys tell me, is this linear? Is this linear? It's really kind of like what number 4 is asking in a sense. They tell me that it's linear? No. Oh, it does right here. Constant rate. So a linear relationship means it's changing at a constant rate. That rate, again, remember, the rate of change is what the slope is. So if it's a constant rate, that means it's a line. It's got the same slope. Can everybody take a minute and figure out what the slope is? Don't say this out loud yet. Figure out what the slope is for this problem. Now, on the quiz, several people calculated the slope and it should have been negative, but they were getting a positive number. You've got to be very careful about how you calculate this. So if you want to be very careful, you can take 2 points. Remember the equation of the slope, right? So if I take the points 0.16 and 1.145, the slope would be, I could do 0.145 minus 0.16. So I went this minus this. On the bottom, I have to do this minus this. I have to go in the same direction. So what do you guys get for that?
Negative 0.1.
No.
0.15.
Negative 0.015, right?
Yeah.
Okay. Now, can somebody else tell me, what does that mean?
His blood alcohol is decreasing.
Okay, be more specific. So blood alcohol content is decreasing by
0.015 each hour per hour.
Yes, perfect. How do you know that? Because I look at the top and that's blood alcohol content, and I look at the bottom and that's hours. So blood alcohol content change per hour. That's straightforward. You can just look at the units and you can figure out how to say that. All right. So what is Mr. Bonehead's Y-intercept? That's the name they gave this guy, so leave me alone. What's the Y-intercept? Anybody? What's happening? What's the Y-intercept?
This is my weakness. I don't know how can I find the intercept.
Okay, so tell me when a line hits the y-axis, like right there. Can somebody please tell me what is the value of x? Like, what is this point?
0,
Yes.
negative 2.
Of course, right? That point is 0, negative 2.
Mhm.
All right, what if the line did this and it hit there? What is this point?
Sorry? Right.
0, 4.
What do you mean by right? Sorry.
Hold on.
Oh, yeah.
There we go. Okay. 0,
4.
Any line I draw, the y-intercept will look like 0 something. Yes? Y-intercept must look like this, 0 comma something. So the y-intercept is always when x equals 0. So let me ask again, what's the y-intercept? Which point?
0.
Yes.
The first one.
Yes, the first one. Yes. That is the y-intercept right there because x is 0, which means this is on the y-axis. So when you tell me answers to intercept questions, right? Could this possibly look here? Look right here. Here we go. Right here. See it? Right there. Could this be an intercept of a problem? Could this be an intercept? Could this be an intercept? A y-intercept or an x-intercept?
No.
Hell no.
No.
It would not sit on one of the axes. So how could it be an intercept? All right. Could this be an intercept?
Yes.
Yes. In fact, what kind of intercept is it?
X.
X-intercept, exactly. Because X is 7, when Y is 0, it must sit on the X-axis. I love it. So intercepts are not abstract, weird things. No. The X-intercept is when Y is 0. The Y-intercept is when X is 0. It's crazy. All right.
Excuse me, Professor.
Yes.
Can you tell us the formal explanation about the intercept?
I just did.
Oh, one more
X-intercept.
time, please.
X-intercept
Formal.
is when Y is 0. Y-intercept is when X is 0. Done. So here's an exciting one. What kind of intercept is this?
This one is Y-intercept.
Y-intercept.
It's both. It's both.
Both.
Because Y is 0, which means it's an X-intercept, and X is 0, which means it's a Y-intercept. So isn't that the one place where a point can intersect both axes? Because that's where both axes meet. Good Lord, Jeff, what is that? So they meet here. So that point, what axis does that point sit on? Both. So it intercepts both axes. I really want this to be nothing amazing, nothing weird. That's all intercept means, is which axis does it intercept? 0, 0, 0, 0 intercepts both. All right, now coming back to this one specifically. This point, what does it tell us physically? They actually tell us in the write-up. They actually tell us way up here. They tell us exactly what that point means.
It tell us at the beginning it was the rate of alcohol in the blood was 0.16.
Yes, there you go. At the beginning, at 2 a.m., his blood alcohol content was 0.16. I like it. I like it. Okay, okay. I'm going to clear all this away. There it goes. You guys ready? There's a lot up here. Let me give you a minute. I am recording, right? I think I am. Yes. All right, here it goes. It's all going to go away. Here it goes. And you're all like, please take it away, Jeff. I don't want to look at it. Okay, all right. All right, so now, of course, we get to number 6. So let me remind us of what we know. We know that the Y-intercept is 0.16. We know that the slope, somebody help me out. What was it again? I forgot already. 0.015? Is that what it was?
Yeah, that's what
Yes,
it was.
yes, that's right.
And so what would the, in fact, what letters do you guys want to use? I guess I should ask. Yeah, X representing hours. Oh, okay. So they tell us which letters to use. So what would the equation be? What's going to go in front of X? How much is it?
Negative 0.015.
Yeah, because that's going to be how much is changing per hour. And then where did it start?
0.16.
Yeah, 0.16. I like it. So that's Y equals mx plus b. Let me just make this canon now. Slope. B is the Y piece of the Y-intercept. So what I like to think is, doesn't it start at 0.16? And don't I subtract an amount from that every hour? So it starts at 0.16 and then I subtract so much from it per hour. That's why mx plus b makes sense. B is kind of like where I start. Mx is how much that changes over time. Yeah, I don't care about number 7. Blah. All right. So there's the equation that models this situation. Will every situation in the universe be linear? Oh, hell no. Right? So let me clear this. In fact, this situation is probably not exactly linear, but it's close enough, I guess. We're not going to use a graphing calculator. All right, let me see. Yeah, I think I want to keep. Let me look ahead a little bit. Yeah, okay. All right, we can do quite a bit more with this. All right, we're gonna finish that up tomorrow, I think. Just looking ahead to the problems. So they're gonna give me a big kind of write-up, and I have to figure, or you have to figure out what's the slope, what's the y-intercept kind of stuff, so you can get an equation set up. So those are the two best pieces of information to know to get an equation set up, is the y-intercept and the slope. Let's see, blah, 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 blah. You have to draw an equation, draw a line, I mean. Yeah, okay, cool. And yeah, so not anything too freaky in the, oh, this homework is nice and long. Look at this. Ooh, goes up to 17, kick ass. Okay, all right. But I think that's, I'm gonna stop there. That's enough for today. I don't want to get too deep into that. We'll continue going with that problem tomorrow. Okay. So let me know if you need to hang out, if you have any questions. Otherwise, you're free to go.
Thank you, Professor.
Sure.
Thank you.
You're welcome. All right, guys. I'm out of here.